Good morning. So today we're doing the very last lesson in Unit 11, which is solving radical equations, and the very last lesson for Algebra 1. I'm sure you all are happy, but it's sad for me. So we're going to solve radical equations by isolating the radical on one side of the equal sign and then squaring both sides of the equation. So it's going to be similar to solving equations where you're isolating the variable, but in this case, it's going to be the radical, which contains the variable in it. We're going to do about 10 practice, and then we're going to do a few problem-solving problems. The first one is the square root of x plus 6 equals 14. So the square root or radical is on the left, but I also have a 6. So I have to get rid of that 6 first. To do that, I subtract 6. And when I do, I get the square root of x equals 8. So to undo a radical, that is the square root in this case, you square it. When you square a square root, it makes the radical go away. It's the same as saying turning this into x to this 2 over 2 power. But really, essentially, when you square a square root, it goes away. If you had a cube root and you cube it, you're taking it away and you have just the variable. So you end up with x equals 64 because 8 squared is 64. If you plug that back in, the square root of 64 is 8. 8 plus 6 is 14, so it works. The next one, the square root of x over 3 equals 7. So the radical is isolated on the left. There's nothing else on that side. So to undo that square root, we're going to square it. And we're going to square both sides. That takes the radical away and we get x over 3 equals 7 squared, which is 49. Now to get x by itself, I'll multiply by 3. And that makes it x on the left and 147 on the right. Okay, and again, you can plug these in and check them. The square root of 5x minus 6 equals 4. So to solve this, I need to isolate the variable on the left, and I'm going to add 6. And when I do, I'm left with the square root of 5x on the left and 10 on the right. To undo a radical that is the square root, I square it, and I get 5x equals 10 squared, or 100. When I divide by 5, I get x equals 20. So far, so good, hopefully. Number 4, the square root of 3x equals 2 times the square root of 15. So you'll notice you have a radical on both sides, but the one that you're trying to solve for is the one that has the variable. In this case, it's the one on the left. So we're going to go ahead, and since it's just the radical on the left, we're going to square it to get rid of the square root, and we'll square the right side as well. By squaring the square root of 3x, we end up with 3x. When we square 2 times the square root of 15, that 2 goes to the 2 on the outside, so that's 2 squared, or 4. And 5 times 15 is the square root of 225, or just 15, which you'll see in a minute. So we get 3x equals 4 times 15, and 4 times 15 is 60. When we divide by 3, we get x equals 20. Okay, we're going to go on to number 5. Number 5 is 8 equals the square root of 5a over 4 minus 2. So this time the radical's on the right, and I also have a minus 2. So to get rid of that 2, I'm going to add 2 to both sides, and I get 10 equals the square root of 5a over 4. I want to get rid of my square root by squaring both sides. I get 100 equals, when I take the square root of something squared, I get just what's inside, which is 5a over 4. I need to get a by itself by multiplying by 4, so 400 equals 5a. When I divide by 5, I get 80 equals a. 80 equals A. All right, number 6. The square root of 2n minus 4 over 8 equals 2. The radical's on the left. There's nothing else with it. So to get rid of the square root, I will square it, and I will square the other side. On the left, I'm left with 2n minus 4 over 8 equals 4. I'm going to get n by itself by first multiplying by 8, and I get 2n minus 4 equals 32. Add 4. 2n equals 36, so n equals 18. Okay, number 7. The square root of 2m squared minus 10 equals 4. I have the square root isolated on the left, so to undo that radical, I'm going to square both sides, and I get 2m squared minus 10 equals 16. I'm going to add 10 to the other side, and I get 2m squared equals 26. I'm going to divide by 2. I'm going to get m squared equals 13. Now, I want just m. So this time we want to get rid of something squared. To undo something squared, we square root both sides. And when we square root both sides, it's positive or negative square root of what we're doing. So that takes care of that squared, and we have m. M equals positive or negative square root of 13. And 13 does not have any perfect square factors. So I'm done. Okay, we're going to do 3 more. Number 8. Number 8 is the square root of 5b squared minus 36 equals 2b. Again, the variable and the radical, the radical is on the left, and we need to get rid of it, so we're going to square both sides. When we do, we're left with the radicand, which is 5b squared minus 36 equals, the 2 is going to the 2, so 2 squared is 4, and b squared is b squared. Now we're going to make sure that we get like terms on the same side. I'm going to subtract 5b squared. I get negative 36 equals negative b squared. To get b by itself, I'm going to divide by negative 1, which gives me 36 equals b squared. When I take the square root of both sides, it's positive or negative. So I get plus or minus 6 equals b. You should always put those in to make sure that they make it true. And let's see if it does. So when I check this solution, I put in first positive, so I get 5 times 6 squared minus 36 equals 2 times 6. 2 times 6. All right, so we get 36 times 5 is 180 minus 36 equals 12. And this is still under the radical. When I subtract 36 from 180, I get 144 equals 12. So 12 equals 12. So we know positive 6 works. Now let's try negative 6. So we put it back in 5 times, and we have negative 6 squared minus 36 equals 2 times negative 6. Okay, when we square a negative, it's still a positive, so that gives us 36 times 5, which is 180 minus 36, equals 2 times negative 6, which is negative 12. When I take the square root of 144, it equals 12, and 12 does not equal negative 12, so our only solution here is b equals 6. All right, let's try another one. Number 9. The square root of x squared plus 9 equals 3 minus x. To undo the radical, I'm going to square both sides. Okay, so when I square this radical, it comes off, so I get x squared plus 9 equals, this is 3 minus x times 3 minus x, which means I'm going to FOIL. So I get x squared plus 9 equals 9 minus 3x plus x squared, because remember, it's first, outer, inner, last. So x squared plus 9 equals 9 minus 6x plus x squared. What's going to happen here? My x squareds are going to disappear. My 9's going to disappear, so I have 0 equals negative 6x. I'm going to divide by negative 6, and I'm going to get 0 equals x. Let's go ahead and make sure that this works. So when I put in 0, I get 0 squared plus 9 equals 3 minus 0. 0 squared is 0 plus 9, that's the square root of 9, equals 3 minus 0, which is 3, and 3 equals 3. So that is a valid solution. Okay, let's go to number 10. The square root of a squared plus 3a equals 2. To undo the square root, I'm going to square both sides, and I get a squared plus 3a equals 4. This looks like it's going to create a trinomial, so I'm going to move my 4 to the other side and set it equal to 0. So I'm looking for factors that multiply to negative 4 and add to 3. And those factors would be negative 4, and, it's going to be positive 4 and negative 1. There we go. So we have a plus 4, a minus 1 equals 0. We set each of them equal to 0. A plus 4 equals 0. And a minus 1 equals 0. So a equals negative 4 and a equals 1. We have to check these solutions. We'll start with negative 4. The square root of negative 4 squared plus 3 times negative 4 equals 2. Negative 4 squared is a positive 16 minus 12. Positive 16 minus 12. And so when we do that, we get the square root of 4 equals 2. And is that true? Yes, it is. So let's try 1. This 1 squared plus 3 times negative 1 equals 2. 1 squared is 1. Plus 3 times negative 1, that's negative 3. Does it equal 2? Well, that's going to give me a negative 2 underneath. So I have the square root of negative 2 equals 2. That's not true. So a equals 4 would be the only solution that works. Oh, wait, did I call that a negative 1? Hold on here. That's a positive 1. So let's go back and do this. So this is 1 plus 3. So that is the square root of 4 equals 2. So 2 equals 2. 2 does equal 2. So that works. So we had a negative 4, which we squared and got positive 16 minus, so they both work. Okay. So that is the end of this part of solving. We're going to come back together and do 4 remaining problems, and then that's going to be it. So I'll see you for part 2.